My name is R. Crosby Lyles, and this is News from the Can. This is a follow-up to the last video that I did, Worse Than CO2, Norilsk, Russia, Ground Zero. So let's just get right into it. Here is this is the 2-meter temperature anomaly, which is 2 meters above the surface. So it's the surface. It's basically 2 meters above the surface, whether it's sea surface or ground level surface. And you'll notice here, if you look up here, it says 1979 and 2000 base. So the question that I've had in my mind, you know, as I was doing the last video, and I run across this every now and then, that the baseline for 2-meter temperature anomaly, which is atmospheric temperature, is 1979 and 2000, but the temperature baseline, temperature baseline for sea surface temperature anomaly is 1971 to 2000 base. And it looks fishy. You know, it's like, well, why do they do it like that? There's a lot of things being said about how much energy is stored in the oceans, you know, how much the oceans absorb from the sun, and how many trillion watts of energy would that be, and blah, blah, blah. There's like a hockey stick, a very compelling looking hockey stick from NOAA that has to do with sea surface temperature. That the sea surface temperature is going up and up and up and up. The thing about it is, though, when sea surface temperatures go up, then there's more evaporation, and that means that there's more cloud cover. So there's necessarily got to be a feedback involved there. And if you look at this map, you'll notice that there's a lot of blue in this map. I don't want to digress too much on this, but I did some checking. So basically the question is, why? You know, why is this 1971 to 2000? And of course, the 70s, early 70s, the temperatures in general were cooler in the early 70s. There was a little bit of dip in global temperature. Now, if you go over here to, this is NOAA, National Center for Environmental Information. The link is in the description. The link to all this stuff is in the description. And if you look at this, their baseline is the Industrial Revolution, is 1880 to 2022. Now, one thing that we have very good information on, interestingly enough, and it has to do, it's because of brewers. It's because of beer brewers. To brew beer and other things, you have to have a very good way of measuring temperature, because brewing lagers and things like that, you know, there's a temperature dependence, and you can mess your beer up if you're not brewing at the right temperature, if you're not brewing or you're not letting it ferment at the right temperature. So temperature is very important for brewers. And a lot of your, you know, like Fahrenheit and a lot of the big names in thermodynamics were brewers. Or about the brewers, the one thing that we know very well is sea surface temperature since 1880, because that's something that they was measured regularly by ships in the oceans. They kept track of sea surface temperature very well. So this is pretty well known since the 1880s. And maybe even before. Sea surface temperature was very well known. So that's the baseline for this information here. Now I want to show you something. If you go down, you can go down here and you can look at the year, and it goes all the way back to 1880. And then there's a ranking over here on the side. You'll see that 2022 is ranked 142. So 1880 to 2022 is 142 years. That's it. So we're the highest, 142. This is the, what do I have this on? This is land. So the land anomaly, for land temperatures, if you look at this graph right here, you'll notice that there are some negative departures. 1985 was a negative departure for land surface temperatures, and 1992 was a negative departure, and 1978. And 1976, and 1972, and 1971. So these are some negative, and that's because there was some volcanic. Mount Pinatubo is, I believe, responsible for the 1992 lower than average departure of land surface temperatures. 1985 is a little bit of a surprise, but because I remember that there was a hard freeze in Florida in 1983. The temperatures were in the teens in north central Florida for like a week. We had an oil burner furnace to keep the house warm, and the oil froze in the tank. So we had to go buy diesel fuel. And that was in 1983, but you can see there's a dip there. 84 was also cooler, but it wasn't lower than baseline. It was still above baseline. And the next year was above baseline. And as you go along to the right, it goes up. And so this is actually 1.26 degrees above base for the land. So, but if you look at land and ocean, which is a combination, if you look at ocean temperatures, and you got to plot this, then it's below a degree. So we're talking at 137. 2022 is ranked 137. 2019 is ranked 143. So that's years, because you're talking about 1880 to 2022 is 143 years, something like that. Is that right? Yeah. 142 years, 143 years. 2019 is ranked 143, but 2022 is ranked 137. So when you look at 1971 is ranked 65th, and it's negative 0.02 degrees. And then 1976 is ranked 66th, and it's 0.01. So the 70s, there was a dip in temperature and sea surface temperature. So you have to ask these guys, and this is the Climate Change Institute, but they get their information from the GFS, from OSHA, and NCEP, which is National Center for Environmental Phenomenon. And they study things like stratospheric intrusion, which is a folding of the tropopause, which causes cold temperatures to dive down to the surface. This is something that Art Bell and Whitley Strieber talked about. But because those guys are average schmoes, you know what I mean? They're non-scientists. They don't really get a lot of attention. But they talked about things that ended up being studied by NCEP, the National Center for Environmental Phenomenon. Actually sent up a satellite to study these things. So the first place I ever heard about it was from their book, The Coming Global Superstorm, that they made The Day After Tomorrow out of. And then after that, it turned into, Venus Earth. So, but why would they do that? Why would they set the baseline temperature different? Because the sea surface temperature anomaly looks way fucking worse than the 2-meter air temperature anomaly. And so if they set this, how would that look if it was 1971 to 2000? But you don't have to worry about that because, the NOAA site over here has kind of got that covered. So here's your ocean, and, the temperatures are up. I think this is basically their hockey stick right here. Okay. So here's your land and ocean. So they must somehow or another put them together, and so that it evens out, aggregates, whatever the deal is. And there it is. I mean, it's clearly, once you get past, they got a spike here in 1998. It went down for a little while, and then fracking en masse started right around 2006, 2005. 2006, somewhere in there, and then that's when the temperatures started going up, because you had massive releases of methane in the atmosphere from fracking. That's a big thing. So methane that's a whole big rabbit hole. I don't want to go into that just at this particular moment, but the argument that I made was sulfur dioxide is way, way worse. This is the National Institute of Environmental Health Sciences. Health education, funding opportunities, careers, and training. Your environment, your health. Resources for scientists articles and journals, climate change and human health literature portal. So and I know this is just one source, and the reason, okay, so this is one source. It's something to look at. I'm sure you can find a lot of other stuff elsewhere, but when I say that sulfur dioxide emissions are more important than CO2, this is kind of a known thing. I mean, there's not really, if you were to go and ask any climatologist or any real scientist about this, they kind of sort of would agree with you with a shrug, but they don't really talk about it, I guess because, I don't know why. I mean, we did something about acid rain way back when, and basically, I think it costs money to remove sulfur from fuel. Where this comes from is it comes from sulfur compounds in diesel fuel principally. And that could be marine diesel fuel that runs cruise ships, all kinds of ships. All ships basically run on, they can run on just about anything, but they principally run on marine diesel. And so that's all your cargo carriers, and your cruise ships and things like that. And very recently, I went on 2 different cruises, a rock and roll cruise. I don't want to go into much more detail than that, but these specialty cruises with Royal Caribbean, and they did a fuel change. The first cruise that I went on, I noticed and took pictures of, if I'll have to find them and put them up, the emissions from the smokestack of the ship were clear. I mean, it just looked like, clear smoke, like what you would see coming out of a car or a truck or something like that. It was obviously they might use gas turbine engines to generate their power, because I believe cruise ships run off of, have electric motors, and that they basically just generate electricity, store it, and then use it to drive the ship. The smoke coming off the ship on the first pass, and I believe that was in 2018, was clear. It was or colorless, shall we say. So it didn't really look like smoke. It looked somewhat, like smoky, but not too much. The next year, they had made a change, and they had something in the literature to tell you about the ship and stuff like that in 2019. And you could see when they revved up the motors, when they started producing more energy, the smoke had a very light beige green color to it, like a white green, which is sulfur. So they said they had this thing where they did something with seawater, or they had some sort of additive, and it's supposed to clean the fuel or clean create a cleaner exhaust. And I'm not sure what the deal is with that, but basically my feeling about it is that they, because it costs money to take the sulfur out of fuel. They have to use chemical means and other things to remove sulfur compounds. Natural gas and diesel fuel. You can make diesel fuel out of natural gas, by the way. So in 2019, they somehow or another, I got the feeling that they were not bothering to remove the sulfur from the fuel that the ship was using. So that means that sulfur emissions from marine sources like ships and things like that sulfur is going to go right into the ocean and would necessarily contribute to sea surface temperatures. Sulfur emissions. Let me just read you this real quick. This is the abstract, and because it's on the front page and stuff, the link is in the description. Global climate change part of the 20th century appears to have been initiated primarily by major changes in volcanic activity. Sulfur dioxide, SO2, is the most voluminous chemically active gas emitted by volcanoes and is readily oxidized to sulfuric acid normally within weeks. But trace amounts of SO2 exert significant influence on climate. All major historic volcanic eruptions have formed sulfuric acid aerosols in the lower stratosphere that cooled the Earth's surface, similar to 0.5 degrees C for typically 3 years. While such events are currently happening once every 80 years, there are times in geologic history when they occur every few to a dozen years. These were times when the Earth was cooled incrementally into major ice ages. There have also been 24 times during the past 46,000 years when major volcanic eruptions occurred every year or two, or even several times per year for decades. Each of these times was contemporaneous with very rapid global warming. Large volumes of SO2 erupted frequently appear to override the oxidizing capacity of the atmosphere, resulting in very rapid warming. Such warming and associated acid rain becomes extreme when millions of cubic kilometers of basalt are erupted in much less than 1 million years. These are the times of the greatest mass extinctions, when major volcanic eruptions do not occur for decades to hundreds of years. The atmosphere can oxidize all pollutants, leading to very thin atmosphere, global cooling, and decadal drought. Prior to the 20th century, increases in atmospheric carbon dioxide CO2 followed increases in temperature initiated by changes in SO2. By 1962, man burning fossil fuels was adding SO2 to the atmosphere at a rate equivalent to one large volcanic eruption each 1.7 years. Let me read that again. By 1962, man burning fossil fuels was adding SO2 to the atmosphere at a rate equivalent to one large volcanic eruption each 1.7 years. Global temperatures increased slowly from 1890 to 1950 as anthropogenic sulfur increased slowly. Global temperatures increased more rapidly after 1950 as the rate of anthropogenic sulfur emissions increased. By 1980, anthropogenic sulfur emissions peaked and began to decrease because of major efforts, especially in Japan, Europe, and the United States, to reduce acid rain. Atmospheric concentrations of methane began decreasing in 1990 and have remained nearly constant since 2000, demonstrating, now this is from 2009 is when this was written, since 2000, demonstrating an increase in oxidizing capacity. Global temperatures became roughly constant around 2000 and even decreased beginning in late 2007. Meanwhile, atmospheric concentrations of carbon dioxide have continued to increase at the same rate that they have increased since 1970. Thus, SO2 is playing a far more active role in initiating and controlling global warming than recognized by the Intergovernmental Panel on Climate Change. Massive reduction of SO2 should be a top priority in order to reduce both global warming and acid rain. But man is also adding 2 to 3 orders of magnitude more CO2 per year to the climate than one large volcanic eruption added in the past. Man is also adding 2 to 3 orders of magnitude more CO2 per year to the climate than one large volcanic eruption added in the past. That is an order of magnitude is in the exponent. So you got times 10 is an order of magnitude. So when they're saying 1 to 2, so it's times 10 or times 10 to the 2, which is 100. So it's 10 to 100 times the amount that a large volcanic eruption would add in the past. Thus, CO2, a greenhouse gas, is contributing global warming and should be reduced. We have already significantly reduced SO2 emissions in order to reduce acid rain. We know how to do it both technically and politically. In the past, sudden climate change was typically triggered by sudden increases in volcanic activity. Slow increases in greenhouse gases, therefore, do not appear as likely as currently thought to trigger tipping points where the climate suddenly changes. However, we do need to start planning an appropriate human response to future major increases in volcanic activity. And that's one of my big things on here is that, solar panels and wind farms are fine and dandy until they get hit by vast amounts of volcanic ash. And there's something called, and I'm going to make a video about it later, a term that I use, I don't know if anybody else has used it, but a term called gray out. And basically what the idea is, I haven't seen anybody else talking about this, but this is just how I see it. We're ended up with a lot of CO2 in the stratosphere. because the methane, when you release methane, it goes right for the stratosphere. As it reacts with oxygen on the way up, you end up producing ozone, and which is a greenhouse gas. But as it gets up into the stratosphere, it reacts with oxygen and produces carbon dioxide and water vapor. And that carbon dioxide and water vapor gets all the way up into the stratosphere, all the way up high into the stratosphere, and maybe even up into the mesosphere. Greenhouse gases in the stratosphere causes global cooling. There's that. But then there's this other thing, where when you end up with a lot of carbon dioxide in the stratosphere, what goes up must come down. CO2 has a molar mass of like 46, something like that. So it's heavy. You know, it's a heavy molecule. And what goes up must come down. So eventually, you know, you reach like a tipping point. A lot of these things are exponential. It has to do with geometry, you know, geometry of particle spacing and things like that. But when you get to a certain critical mass, then a lot of that CO2 could kind of sort of slowly rain out at the same time, in which case you would get an effect, something called gray out, where basically it's gray out all the time, where you have a reduced amount of solar radiation hitting the Earth. You know, this is a phenomenon that I'm sure happens naturally because you get deposits of clathrate that can be impinged upon by a volcanic eruption or something like that, and you can get large releases of methane gas that leave large amounts of carbon dioxide and water vapor in the stratosphere, which can all rain out, you know, kind of sort of at once, or you know, in a relatively short amount of time. And so carbon dioxide aggregates water droplets. It attracts water. It benucleates water droplets. The carbon dioxide molecule is very soluble. So what it'll do is it'll change the electric field of the water particle, and it'll cause nucleation. It'll cause droplets to form. And when that happens, you get like a fog. And so when you have that, then you end up with heavy cirrus clouds, and in the lower atmosphere, you know, the same thing happens. If you got a lot of carbon dioxide in the atmosphere, then you get fog. If you've ever gone and gotten dry ice, you can see that. Well, of course it's cold, but if you are doing like a stage presentation or something like that, they used to use dry ice all the time. Throw some dry ice into a bucket of water, and that fog comes out of the bucket and crawls along the floor, and it's very persistent. They used to use this in television shows a lot, like Gilligan's Island and things like that. If there was a dream sequence, you know, somebody was having a dream sequence, and they would use the dry ice, the fog from dry ice. And it's really creepy looking and stuff, but it's fog. And fog is, you know, when you have a lot of carbon dioxide, you've got a lot of fog. That's just how it is. And it can be very overcast. Like Europe used to be like overcast a lot more than it is now. Back in the days when they were burning a lot of coal, you know, in the 50s and things like that. You know, all your stories about werewolves in the bog and things like that. It was very foggy out in England. England was a very foggy place, and that's because they were burning a lot of coal and things like that. They were burning a lot of fossil fuels, and so there was a lot of carbon dioxide in the atmosphere, and SO2, frankly. So, you know, the worst climatological disaster that ever happened in England back in the 50s, and like thousands of people died because they had an inversion, and it just contained all of this smog, you know, in the London area, and like literally thousands of people died. And you're talking about something heavy duty, but that happened back in the 50s. So anyway, a lot of this crap is known already. And as I said in my last video, I believe that you've got fuel producers, maybe even marine fuel producers, who want to make a little bit more money, or having trouble making ends meet or whatever. They want to not have to take the sulfur out of their fuel. So they use fatigue over global warming to deregulate sulfur emissions in fuel, which is a big, bad mistake, because sulfur, as this paper rightly says, sulfur emissions, low-level sulfur emissions, hit the sea surface and cause sea surface temperatures to rise out of control. And that's when sudden changes. I've mentioned in this very paper, and you can read it for yourself. It's attached. link is in the description, that additions of sulfur dioxide into the atmosphere, into the lower atmosphere, and depending on what kind of time frames you're talking about, can cause sudden changes in the climate. So hot or cold. So it's a thing. But I want to show you this tool here. Okay, that's that. This is sort of, in a way, to me, this is kind of definitive, and you can check the baseline because they're using the 1880 to 2002 baseline. And it's pretty, it's pretty definitive, I would say. That's land and ocean. I did the thing here, so yeah, it's that. Okay. But here's this. So now this is the 1971 to 2000 base. So what this will do is, because it's including colder years in it, it's going to sort of it's going to make it look warmer. And it might even look warmer if they use the 1880 to 2022, if they have that. But here's what I want to show you. To me, this is really fascinating. This is this year, 2022, year to date. See how it moves in waves? Now this is right over here. I wonder if I can. That's the Kara Sea right there. It's iced over. And it doesn't start de-icing until July. Okay, so I'm gonna stop this for a second, but you can see how it's, watch how it, you can see it, there's like waves of temperature. So let's stop that there, and let's just go to July. July is important because that's at the point where, July is the point where the ice starts to melt. Actually, June is where the ice starts to melt. But you can see over here, it's Novaya Zemlya. So that means Zemlya must be like mean island, I guess. New Siberian Islands over here. But this is telling you that this is the Kara Sea. Novaya Zemlya. And the little islands up here is the Franz Josef Land. Svalbard's all the way over here above Norway, Sweden, Finland. Okay. So these islands here, that tells you that you're in the Kara, that's bordering the Kara Sea. It's the body that's between the Barents Sea and the Kara Sea. And the Kara Sea is the one that's getting anomalously warm sea surface temperatures. So this is all the way over here to the right. There's a little thing that you can typically click that will move the map over so it's a little bit easier to see, but it's up here in the far right-hand corner. That's Novaya Zemlya, if I'm pronouncing that correctly. And you can see in July the sea surface temperature is taken over because the ice is melting, but there's still, you can see there's ice attached there. Still, it's amazing how they do this stuff, right? And there you go. You have that is 6 degrees above nominal. But if you look across, oh, look at that. Well, that's fascinating. That sea surface temperature actually starts to dive down. To look across the map over here, there's also elevated sea surface temperatures in the Sea of Okhotsk. That there is elevated sea surface temperatures, and right here where the Kuroshio Current terminates. The Kuroshio Current comes up the outside of the Philippines and goes on the eastern seaboard of Japan, and then comes out and over into the middle of the Pacific Ocean and dives down right here where you see this big blob in the central northern Pacific Ocean, which is, the center of it is 6 degrees above nominal. Because it occurred to me that it might be a mistake just focusing on an area that's under cleanup, that's been being cleaned up for a while. So they stopped a lot of the air releases, apparently, of SO2 in the Norilsk area. And I don't know what they were doing, but there was a release, as stated by Simon Whistler in the video that I talked about before, was talking about the most polluted city in Russia. That maybe that release was related to their nickel mining operation or something, and I'm not really so sure about that because there was an oil spill. And when the oil spills, it has a red coloration. So apparently, and there have been several. There was a big one in 1994, and then a big one recently. So I was going to lay the blame for a lot of this sea surface temperature on that, but it might just be, polar amplification of, the usual suspects overall. Of course, China and India. So I don't want to lay too much at the feet of that, because you can see Cam's Copernicus, I think, is a pretty reliable source, probably. And they've got some sulfur emissions up there, and there's other stuff going on. Polar amplification is a thing. You've got releases of methane gas, you've got releases of carbon dioxide and things like that, and other stuff, nitrogen dioxide. But this should not be ignored. Petropavlovsk-Kamchatsky is a city and administrative, industrial, scientific, and cultural center of Kamchatka, Russia. Its population is 179,780. The city is widely known simply as Petropavlovsk, literally city of Peter and Paul. The adjective Kamchatskia was added to the official name in 1924. And geography, the city is situated in high hills, surrounded by volcanoes. Surrounded by volcanoes. Russia's largest submarine base. Got a submarine base and a lot of volcanoes. So it could be from volcanoes, or it could be from processing fuel or something like that. In any case, on the eastern coasts of all of these Western Pacific lands, there's a lot of emissions of sulfur dioxide. And there you go. But anyway, looking back, so we're on July. We'll just leave it locked where it is. You start going back. There you go. Yeah, it's okay. So here you've got some anomalous temperature in the middle of July up here in Baffin Bay. But they were seeing, so weird. That's so weird. 2017, maybe it was just in July. 2017, 2018. Anomalously high temperatures in the Baltic Sea. The Baltic Sea is apparently that area. You've got some anomalously high temperatures there too. 2019. Baffin Bay doesn't look that bad. Oh, here we go. You got a burst here in 2019. July of 2019. There's some anomalous temperatures up in Baffin Bay. 2020. More, and this is in Hudson Bay. This is a lot of anomalous temperatures. But then right over on this side, you got some anomalously lower temperatures too. And then 2021, it's an oscillation. It's over here, below the Sea of Okhotsk, right, and the Sea of Japan, right off the coast of North Korea, and of course back over here. So it might be improper to lay all that stuff at the feet of the nickel industry, in Norilsk, but they did just have a spill there apparently recently, in recent times. So and apparently the Russian federal government has fined the piss out of those people, like several million, couple of billion dollars, or rubles, or I think it's in it's billions of dollars in value, so it's a lot. They apparently don't. They're kind of cracking down because Russia's like the poster child for environmental disasters of all kinds, radiological and otherwise. So they're getting serious about it, and I applaud them for that. So basically, I mean, there it is. What else do you need to know? There's a lot to talk about, but what you see here looks a lot different because the baseline is different. 1979 and 2000 is not going to consider lower temperatures that occurred in 1971, 1976, and what that will do is that will cause your anomalous. It will sort of like subdue. It would be nice if they were both the same. Why they do that, I'm not really sure. I'm not really sure if they're trying to make one look worse, if they're trying to make sea surface temperatures look worse, or if they're trying to make the 2-meter temperature anomaly look less bad, or I'm not really sure what the deal is with that. But to me, the definitive thing is the 1880. The entire Industrial Revolution, 1880 to 2022. That's pretty definitive because I mean that's when the emissions started, is in 1880. And when you look at that definitiveness, land and ocean, there it is, kind of hard to argue with. And these temperatures were very reliably measured because we had instrumentation, and it was done. It was something that was done and recorded from ships traveling throughout the oceans. There was, extensive sea travel in the 1880s, extensive measurements of these things, and I think that those instruments that they used were pretty good, as far as I know. So this is something that was well kept track of, maybe even further back than 1880. So anyway, that's it. That's all I got. I just want to sort of like keep it real with y'all and give you some tools to look at stuff. I mean, this is the real crap here. Pretty much. So that's it. I mean, pretty much, yeah, we got to do something about carbon dioxide. No doubt about it. No doubt about it. But that doesn't mean that sulfur dioxide is not a problem, and really not a bigger problem. And one of the reasons for that is because sulfur dioxide, sulfuric acid kills everything. It's like pouring Roundup on the landscape. Spraying Roundup on the landscape. It virtually kills everything. And when you do that, then there's no absorption of CO2. It's a synergistic effect. Both together is like devastating. So these are things that are known. I mean, just really widely known. And I say that because our problem is that big money is able to keep people quiet at times when they really shouldn't be quiet, and it allows us not to focus on things that we should focus on a lot of times. We need to be organized. We need a one world government. That's all there is to it. Anyway, that's all I got. My name is R. Crosby Lyles. I gotta start editing this thing, and this too shall pass. We can get through this. Remember, good thing to have is a ham radio, shortwave radio. They're cheap, handheld devices. You can get them on Amazon. I don't sell any of that stuff. Extra provisions, it's a good thing to have because you never know when the shit might hit the fan. Could be a flood, could be large amounts of snow, could be all kinds of stuff. Extra medication for you and your pets, extra provisions, extra water, ways to store and create power that you need to charge your stuff, and You know what I mean? You need those the communication devices in case the cell towers go down and stuff like that. So or you know, you can do it how you want to do it. I mean, you know, what do I know? It's also good to have things to barter. Even if you don't smoke, it's good to have tobacco around and rolling papers. Tobacco, rolling papers, or just, you know, a carton of cigarettes in the freezer or wherever they'll keep. A bottle of booze, even if you don't drink. Aspirin, painkillers like that, you know, over-the-counter painkillers, maybe even Sudafed and shit like that, even if you don't ever need it yourself. These are things to barter with. Diapers, even if you don't have a baby, you know. These are things to barter with, and that's if the shit really, really, really hits the fan. And you can look it up online, you know, things to barter in an emergency. You know, it's just good to have because cash might not be worth anything. But I don't want to go down that road. You'll figure it out. And that's it. Take care, and if you live in snowy environments, keep the snow shovel inside your home. Inside somewhere where you can get to it, so you don't get buried in your house. And that's it. I love you guys. Rate, comment, subscribe, and the abundance of the universe is at your fingertips. The abundance of the universe is at your fingertips. The abundance of the universe is at your fingertips. The abundance of the universe is at your fingertips. See ya.